All right, we're ready to go ahead and continue with the program and move on to our next panel. So I'll start off by introducing our moderator, and then I'll let her introduce the different panelists we have today. So we're really pleased to have with us today for our first panel, Cristin Lyons. Cristin is a partner and head of ScottMadden's energy practice. She has over 25 years of experience in the energy industry. And she and ScottMadden are longstanding members and supporters of WIRES. So I'm happy to go ahead and introduce Cristin on a panel that's going to focus, as I alluded to earlier, on the reintegration of planning, putting Humpty back together again. So Cristin, let me go ahead and turn it over to you and introduce the panelists and get started with the discussion.
All right, thank you. So as Larry said, I'm Cristin Lyons with ScottMadden, and I'm going to introduce our panelists, and then I'm going to spend a moment talking about a little bit of history as to how we've gotten here. So at the far end, we have Steve Martz, who's the Vice President of Integrated Planning at Xcel Energy, a fairly new organization that is kind of one way that the industry is starting to tackle this question of integrating planning. Shawn Schukar, President of Ameren Transmission, has been in that role for how many years now? 7. And again, represents a very different model as we think about planning functions. And last but not least, Carlo Brancucci is the CEO of encoord, which is a software company that's really working on the technical aspects of putting these pieces together. So to get us started, as Larry mentioned, I've been coming to WIRES meetings for, I think, over 20 years. I think I was around when it first started getting rolling. How many of you all were in WIRES or even working in transmission in the early 2000s? Okay, more than I expected, but maybe less than half the room. And if you all remember, in that era, it was as we were starting to look toward FERC incentives, so 679 had not yet been approved. We had a lot of new business models emerging. We had companies like ITC, METC, ATC, TransLink, for anyone who remembers them. We're all starting to stand up with this idea that we're going to see tremendous investment in transmission. And at that point, because we were coming on the heels of wholesale deregulation, it was all about reliable, cost-effective power out of the markets. And as a result, we had a lot of business models that were set up to enable that. What we have today is kind of the remnants of that. So we were focused on least cost power, available to all customers, enabled by robust transmission and generation, central station, generally dispatchable or baseload generation, I might add. We worried a little bit about wind, but not too much in that era. And here we are 20 years later, 20 plus years later, and the resources that are showing up have very, very different attributes. We have business models that are, in many cases, completely disaggregated in parts of the country or remain completely integrated. In markets, out of markets, even within markets, we have IRP processes within MISO. We have full markets in places like New England ISO, where you don't have those regulated assets owned anymore. So anyway, that's a very long way of saying we have taken apart the pieces. And now, as we wrestle with this reliable, affordable, and clean conundrum, planning the system has become much, much more complicated. So with that, these are 3 people who have spent a lot of time thinking about this question. And I'm just going to throw a softball to you all. So starting with Steve, when we talk about integrated system planning, how are you at Xcel thinking about that problem? How do you even define it?
Yeah, thanks, Cristin. So in the last 20 years of working in the power, I've realized I've become middle-aged. And so I have my staff who has told me you can do one of 2 things. You can embrace technology and become more efficient, or you can become like every other middle-aged guy and get really into like World War II history and trivia and kind of go off the rails. So I prepared a response through ChatGPT, which is, I think, cliche and bland, but kind of hits it. Defines it as planning for a utility involves strategically coordinating various aspects of generation, transmission, and distribution to ensure reliable, cost-effective, and sustainable power delivery. So I think it hits the mark. You know, a little bit more specific to Xcel, you know, the way that we think about this, and you kind of foreshadowed it, Cristin. I mean, we changed our organization to do this. We're about a 15,000 person company. And the way that we approached this is we realized that we didn't have the appetite control culturally to fully embrace a matrixed approach to planning, right? We didn't have the cultural Ozempic to make sure that we would do it right. So we decided that we had to move the butts that are in the chairs. And the way that we've designed this is specifically to retain technical consciousness for the system at the highest level of the organization. And I get the privilege of doing that. I get to work across all of our business lines in every single one of our states. Our generating capacity is about 40,000 megawatts. We serve 4 or 5 million people between our different business lines. And so we've defined it in that sense that we need to preserve the requirements of the grid from a technical perspective. And kind of our hypothesis in doing so, I suppose, is that, and Commissioner Christie kind of hinted at it, I strongly agree with him that I wouldn't even say it's a top 20. I think the United States power grid is the engineering accomplishment of mankind. And when you look at like prosperity in our economy, as well as other Western economies, it's predicated on cheap, reliable power and access to cheap, reliable power. The last country to really mess with their power grid negatively was Soviet Russia, and you saw where that goes. So that's kind of hypothesis one for us. Hypothesis two is our customers can't afford for us to do it twice. And so that's where my organization comes into play is we get to think through GT&D and cross-optimizing investment. And I'd say the final thing is, capital allocation is getting harder. We're coming out of 2 decades of quantitative easing, right? It's kind of easy to let capital flow to so many different parts of the economy and the value chain. And frankly, it's just getting harder, all right? And so we've also come to the conclusion that our balance sheet can't tolerate misallocation of capital. So that's Xcel's view of what ISP is and what we need to do.
So I'm just going to paraphrase what you said. The optimization across transmission, generation, and distribution is the primary goal that you're correct. Thank you. Huh?
So I could just say ditto on much of this. At the end of the day, though, for Ameren, I'm one of those guys who held my hand up and I've been around forever. And, if you go back and you sit and think about what we were doing then, we were still pretty myopic to our systems. And today, I think the world has changed. So I expanded a little bit beyond what Steve talked about, which is it's the coordinated planning of transmission, distribution, generation, natural gas, hydrogen, communication circuits, and making sure that all of that fits together to optimize for the customers at the end of the day. Because, it's not just our customers are seeing cost increase. They're demanding a different level of reliability, a different level of resilience than what we have seen in the past. We have to deliver all of that with all of the cost pressures, with the inflation that's occurring today, with the changes that we're seeing, not only in the generation mix, but also in the load and the way that customers are using the data centers that are coming on, the new loads that are coming back from offshoring back to onshoring. All of those things are driving that need. And then for us, we really started seeing it when we were in the RTO, recognizing that it wasn't just what was happening in our system, it was what was happening around our system in the RTO, which really opened our eyes to it. And then, because we sit where we sit, we are right on the edge of PJM, SPP, Associated, which is not in an RTO, TVA, which is not in an RTO. And what every one of those are doing also impacts us. So when I think about coordinated planning, that's a much larger integrated planning. That is a much larger view for us because it takes not only what's happening in our own system and what we're planning for there from a reliability, but making sure that we are working with the munis, co-ops, our next door neighbors, and building those systems out in a way that maintains the reliability with everything that's going to be changing over the next 10, 20, 30 years. Because as you all know, the assets that we're putting in are long-term. And as Steve mentioned, we can't afford, both from a customer perspective and from a capital allocation perspective, we can't afford to be putting things in that aren't needed. And so having to do it that way is what we view as integrated planning.
So in addition to managing internal seams, it's managing seams with your external parties as well.
Absolutely.
Great point.
Carlo?
Thank you, Cristin. First of all, for the invitation. Thank you, Wires. For me, integrated planning is the coordination between existing siloed planning processes, like Shawn mentioned, generation, transmission, distribution, natural gas. And referring to what we just heard from Commissioner Cristin, I truly believe that integrated planning is what is necessary to make the case and defend it for any project we are going to build. While projects may be classified as reliability versus economic versus public policy projects, any project, transmission, generation, storage, distribution project, has reliability, economic, and regulatory impact. Integrated planning is the platform and a practical workflow to ensure that the electrical engineers, the mechanical engineers, the economists, and the regulatory experts not only have a way to understand each other and discuss, but ultimately to agree on what is a good solution or the best solution to move forward.
So to the internal seams, you added the regulatory perspective, which I think is embedded also in what was said by your colleagues here.
Absolutely.
So, and I'm going to focus primarily on the internal seams. As you all look at how this is playing out in organizations, both your own and others, you've got organizational challenges, I would describe them. Process, technology, data. How are you all thinking about those four? Shawn, you want to start us off?
What were the four again?
Org, process, data, technology.
Okay, so for us, because of the separations that we have in the business, and then having two states that are very different in how they think about it. So we have Illinois, that is a deregulated state, so generation is separate, and also is a state that is very focused on clean energy and transitioning as quickly as possible. And then we have Missouri, the show me state, that is they continue to be vertically integrated, generation's owned. They want to move much slower. And so integrating that work from an organizational perspective is very difficult. And so what we've really focused on is making sure that everything that we do aligns from first starting out with the data, right? I mean, that's probably one of the bigger hurdles for us, is that each of us had our own data sets, whether it was, how loads were growing and what our projections were, upgrades that were happening on the system. And then for transmission, it was even more of what was happening around us, right? And so the first thing is just getting all of the data sets together so that we have consistent data sets across that. And then our planning process to make sure that what we are evaluating, given the different concerns from the different states, and then at the MISO, because the MISO has its own set of scenarios that they evaluate, that we align those across the organization and evaluate what each of those means. That doesn't mean that Illinois doesn't have a different build out than what Missouri does, but we look at those different scenarios to identify where we may need to make those changes as we move through. And so processing that organizationally, we really aren't changing. It's really more how we coordinate. And much of that gets driven from our organization, because as the transmission folks, some of it's internal, distribution, natural gas in Illinois, but some of it's external. The generation is done by others primarily, right? And so natural gas in Missouri, while we have a small portion there, that's primarily somebody else. So it takes a lot more external coordination as we think about not only how do we develop our system for what we think we're going to do, but also what do we do for, like what happened in Illinois with the law that gets passed that said you have to identify these hosting areas, and how are you going to support additional electrification and engaging the stakeholders around that. And so we coordinate to the extent we can. It's not to where we want it to be yet, but it is a process that we are moving forward with as we try to get that planning integrated.
Steve?
I mean, you could spend a long time on any of the four topics. I think I'll focus on org and maybe data. So what we're endeavoring to do, and the way that we've kind of set ourselves up organizationally, I agree strongly with your comment, Shawn. I mean, if you want to get into real integrated planning, documentation, process maps need to become your love language when you talk to your org. And I find personally that the wires industry in particular is a little bit undisciplined in this sense. And my juxtaposition for that, right, is we have a nuclear fleet, right? We also have an LNG fleet. A lot of people don't know that about our business. Very high performing organizations. And the way I think about this is kind of the precipice that we're sitting on. is the industry's benefited from like a really good, really consistent design basis for the wire parts of the business since about the 1930s. We built it once. We had a big influx of load in the 60s and 70s with air conditioners. The last 4 decades have been all about conservation. And right now we're dealing with this, really quick accelerating evolution around, changing design basis. And I haven't seen the same like nuclear level discipline that's required to really think about documented, regimented change to the system and how you make the decisions around that change. So what we're trying to design is like a discretion-free but also friction-free environment for decision making across our business lines, GT and D, and as well as natural gas. And I'll probably offend a decent amount of the crowd with this comment. I am an engineer. I self-identify. Engineers are emotional beings. Good Lord. I mean, they do not make perfectly objective decisions. And we are discovering really quickly as we've gotten into and really examined our planning processes. We thought we had these really robust planning processes to work with the RTOs. We thought we had these really robust processes to perform our modeling for resource plans. And like you actually dig into it, you got to get in like 3 or 4 layers deep, and you'll find there is someone in your org making a decision based on like emotion, perception, history, lore, etc. And that's precisely what we're trying to defeat. Because if you go back to our original premise, right, capital allocation's got to get better. You've got to remove the discretion. So that's kind of an organizational piece and lens on how we're trying to tackle this. On the data piece, I mean, an SAP executive told me one time, and I think it's proven to be really true. She told me this about 15 years ago. She's like, utilities are big data companies. You guys just don't realize it yet, and you have no idea what to do with it. And that's really been proven to be true from my perspective. When you have a pretty diverse operating footprint like we do, right? We're in 8 states, and you have the states deciding different decisions. It makes it really challenging to think about, the data architecture that needs to go into your planning process. Because like take like smart meters as an example. We have every flavor of advanced meter or kind of incumbent meters that you can find. We have AMR, we have AMI 1.0, we have AMI 2.0, and we have actual just like old meters. We still have meter readers in parts of our states, which is fascinating. So you think about like the rate at which you can procure data collection and new data, right? Like that's got to be in the architectural underpinnings of how you plan a new system, how you change design basis. That's something that we're trying to homogenize and take a more standardized approach. And frankly, we might get to a point where we just say, look, the juice is worth the squeeze. We don't necessarily care if we get recovery on this. We're just going to do something like AMI because it's where we got to go, because we think the long-term benefit is going to benefit all of us in terms of optimization. So again, I could spend a lot of time on data. I give ourselves like a D+ on data. I give the industry a D+, C-, somewhere in there. It's got to change and change really quickly. I also think kind of embracing non-traditional participants in our industry is a must here. And we've invited in a lot of like the major tech companies to really help us rethink this approach because we find we cannot do it internally.
C- might be generous from some of what I've seen on the data side. I'll also take the process needs to be your new love language. We have worked with a lot of companies on these topics, and most of it's not written down. There's the one guy who's been in the industry as long as we have or longer, and he's the go-to.
Yep.
And away you go. And then that person, in this day and age may retire and there's nothing left. So again, I love those comments. Carlo, you're living this right now.
Yeah, maybe I will. Well, I agree with what's been said about data, about the need for available, transparent, and consistent data. But maybe I'll focus more on the people aspect and the technology aspect. The challenge with acting on integrated planning is that the people that today plan the different parts of the system have very different expertise, very different technical languages, and in very few occasions they are in the same room and have an opportunity to learn from each other and understand each other. So to me, the first pass into integrated planning is get these people to truly work together, get these people to start talking about how do they think about planning. A generation planner and a transmission planner, they're modeling and they're planning the same system. One is focusing more on the generators, the other one is focusing more on the wires. But they are supposed to be modeling the same system, because the value of generation is a function of transmission, and the value of transmission is a function of generation. And I could add distribution in there as well. And the challenge is they think about planning differently. Their planning criteria are different. One planner is used to think about time series and how things change over time. The other planner is only thinking about the worst case scenario. And now the question is there a worst case scenario, or can we even detect what the worst case scenario is? One planner is looking much more at the economic metrics versus reliability metrics. The other planner is thinking only about reliability metrics. They need to get in the room and they need to start sharing just practices and thought process in and how they think about planning. That's the first step. The second step is on the technological side, which is they are using different technologies, different tools to plan their system, to inform their planning decisions. And so it's very hard for them to work together when these tools they're not meant to talk to each other, or the data they rely on is inconsistent. I bet in most utilities that have a generation planning and transmission planning team, the way transmission is represented in the transmission planning tool and the generation planning tool is inconsistent. And neither are wrong. They've just been built by different people for different purposes over different timelines. There is a need for them to have a common room first and second platform to work together.
And we did a benchmarking study across a number of utilities last year to look at, one of the things we looked at was organization. And often, particularly on the generation side, the very first executive that those two planning functions report to is the president of the OpCo or the CEO of the HoldCo. And that, again, as much as we want to enable these processes across, it makes it very difficult. You know, and
Can I respond to
Please.
Carlo's comment? I mean, I think it's like so spot on. That's what I mean by like increasing the performance of the industry. Because I can't tell you, I refer to this on my team as like the transmission planner versus the generation planner. It's the mongoose versus cobra fight. I continue to be shocked at how many times we sit down at the table and just like something as simple as like, what's the production output of this asset is completely different. And it's like a couple megawatts, whatever, right? Like these things are consistently off by a 20, 30, 40%. And you see that magnify again, like when we work with our RTOs, when we work with our neighbors. To Shawn's point, I mean, that's where that aperture has to be expanded, because like if we're not all even like thinking about the asset in the same way, right? We have different views of its performance. Is it a Toyota, a Lexus, or a Mercedes? Like you're never going to get anywhere if you all can't even agree on that basic input.
so just curiosity, before those people started reporting to you at Xcel, had any of them met each other?
Yes and no. I'll tell you, I've had to put a lot of money into my travel budget to fly people around and to force them to sit in the same room. And as trite as that sounds, people, you know, I think our industry has operated for 100 years on a commodity basis. That shows up in the day-to-day interactions, and we've had to physically force people to get together. And you know, those airline tickets paid off, if you will. I think we've created a lot more, you know, organic synergies. But my evidence of that is, you know, we'll have our all hands meetings. We'll bring people all the way down to Texas, Wisconsin, North Dakota, et cetera. And we have planning teams that have, you know, like veterans of industry, literally 40 plus years in industry, telling me, like in our surveys and just, you know, reaching out to me directly, I've worked here for 40 years and no one's ever taken the time to fly me to Amarillo to talk to the power plant people. No one's ever flown me to go talk to the ISOs directly. And there's just like, there's this really low hanging fruit out there, just like putting a little bit of money into, you know, a travel budget, creating, you know, I believe as leaders, our job is to create tools and a process of immersion for our teams, and then to provide them vision and hope. And that's kind of how, those are the principles we've used to approach this. And we've come up with some really interesting results by just getting people in the same room.
Yeah. Shawn, additional thoughts there?
So I think, you know, the whole idea of getting people together is interesting in that for part of our business, like the generation and transmission, I think we had more of that interaction, you know, just because of the IRP in Missouri. But on the other side with distribution, that while the people knew each other and they talked once in a while, they really didn't interact a lot. And, you know, we had big disconnects between how the distribution part of the business was thinking about future load growth. And, you know, now we're seeing all of this generation that's wanting to interconnect on the distribution system. that was nowhere in their viewpoint for quite some time. And we were already trying to push that because we were seeing people couldn't get connected up at transmission. So their next step was, I'm gonna go to distribution because I can get connected up faster. And so those interactions have had to increase as we've gone over time. And it's valuable to us, but I think to what Carlos said, having the systems and the processes that work together, because they talk across each other quite a bit.
Yep.
Because they're thinking about it differently.
Absolutely. Go ahead.
Maybe just to comment on the generation and transmission planning, and referring again to what Commissioner Christie said during his presentation, he once said, we need transmission for reliability, and then he said, we need combined cycles for reliability. Both are probably true, but both depend on one another. And the fact that the statement of we need CCs for reliability is probably coming from the generation planning team, and we need transmission for reliability is coming from the transmission planning team, you are suboptimally thinking about this, because you could meet your reliability standard only with CCs. You put one CC in every load pocket, you don't need transmission. You can build a copper plate, you don't need generation, there is enough capacity. Understanding these trade-offs between generation and transmission in terms of cost and reliability and other variables that you may care about on the more public policy side is absolutely essential. And I think the industry is thinking about them separately. There is an enormous need to think about this in a coordinated way.
Which is a perfect lead into what I was going to ask about next. So what we're seeing, we see individual state IRPs, and in some cases, those assume no congestion on the transmission side, which I think is fascinating. I think that's decreasing over time, but that's been historically true. You see RTO planning processes. You see integrated distribution planning processes, and I'm going to point to Illinois as Exhibit A right there. Some of us may have been closer to that than others recently. And what many of these processes are doing is optimizing the assets to which they have access. You know, integrated distribution planning, it's not just Illinois, you've got it in Michigan and Colorado and a number of other states, but really focusing on meeting policy objectives via the distribution system. You know, we are all familiar with the processes from a transmission perspective, in some cases, multi-value assets are being proposed. You know, and MISO is a really good example of that. What are your perspectives on some of those, whether it's state or federally driven processes, and how are they helping or hurting what we're trying to do from an integration perspective?
So I'll jump in since you mentioned Illinois. And I think they help and they hurt, right? So they help because they've caused us to think about what the other impacts are more. So on Illinois, I mentioned the hosting capability, you know, the climate study that we have to do. That ties with what we have to do at the transmission side also. And so as you think about, they're now having to think a little more broad, even though it's their own assets, they're having to think a little more broadly than what they historically have. And I think that that's helped for them to outreach and say, well, what's this really mean? At the same time, because they have these very defined timelines, it makes it very difficult to say, we're going to integrate our planning because I have to get this distribution plan completed in this amount of time. And so there's a friction between those two. Some of it's helpful, some of it is harmful to us.
Yeah, I mean, I'd say we're talking about this a little bit over the break. I mean, what we've seen in our states just is a wholesale desire to shift upstream in the planning cycle from our commissions, and I think that.
So what does that mean exactly?
They want to be involved right from the beginning, and they are also employing, you know, their own staff of planners, which I find like a little bit funny because I have yet to find a commission that's successfully gotten a Plexus or Encompass model to solve, and it cost me a lot of time to go help them do that. I've become a little consultancy for IRPs for our staff. So, like, I get it. You know, they got to regulate us. I think it's totally fine. But I can't help but look at this from just the regulatory efficiency lens of just how disaggregated it really is. And it causes us a lot of strife to have to explain, you know, cross-functionally all these different things to these through these little windows of recovery. So it's like good and bad in the sense of, you know, I appreciate what they're endeavoring to do, but I think, you know, Commissioner Cristin nailed it. It's energy policy has become the battleground of energy politics, and I think like distribution system plans are a really good example of policy leakage issues and policy runaway issues. And like forgive me if your state has a really good construct for it, but like my example of that, my evidence of that is like community solar gardens. Very hot button political issue. It obviously has a DEI bent to it. It sounds and feels really good in terms of, creating policy to enable them through DSPs, but like where it's broken down and like not enabled by, sufficient technical understanding and using the right modeling tools to really understand like their value is basically, we have CSG incentives out there to allow more communities to procure that type of generation on their behalf, but it's completely inconsistent with locational value. And so what we see is cheap land is not where there's grid constraint. And so like that's a great, example of a failure to optimize. And you have financial incentives, right? An excess, a surplus of carrots out there that are not helping the system. And so it's like twofold because you're spending money, right? You're misallocating capital on the CSGs, and then you're paying for the reliability piece on the other hand as well. It's a great double hit.
Yep. Anything to add there?
There is definitely a need for clarity on definitions and process. There's a lot of these IRP, integrated distribution planning and so on. They talk about from the commission, at least with my limited experience, is that they touch on what the plan needs to cover, but not how to approach that. So for example, a lot of transmission and distribution planning is done running physical simulations of your electric network. So primarily power flow simulations in transmission. You may also do dynamic simulations for stability analysis and so on. I've never met, and again, that's just based on my very limited experience, a commission that has the knowledge and the expertise to not just run these type of studies themselves, to really understand or review them properly. And so my question is, and this is more a question I have for you two, is would it be valuable if the commissions had the engineers and staff to do the type of planning, or at least to be able to review the type of modeling that you do? Because at the IRP level, you mentioned Plexus and Compass. These are production cost capacity expansion models. At the end of the day, it's energy balance modeling. Usually both an engineer and an economist can address this type of models. But when you go down to transmission distribution, you primarily are going to need electrical engineers. And I've seen very few electrical engineers working at commissions. Would you want the commissions to hire electrical engineers, or will that create an obstacle for you? This is more, I'm curious.
I kind of brought it up so I can go first, but we'll certainly hand it over to Shawn. I have zero issue with being regulated. In fact, we've actually hired consultancies on behalf of our commissions to help in that process, to give them more tools in their toolkit to help review them. My issue is just with the efficiency piece, right? It's like, hand us over our models. Oh, we can't get it to run. Can you help us? Like, that's the piece that kind of drives me a little bit nutty. In terms of using expertise to help us come up with the best solution, absolutely. Totally fair game. And I'd say that's kind of more of a commission philosophical decision. Do you want to use third parties and consultancies, or do you want to have, do you want to build that internally? I'm indifferent.
Yeah, I think just like Steve talked about, the more the commission knows, the more comfortable they get with the decisions that we make. But I think there is a balance there, because then it becomes, I think Steve mentioned this, there's these biases that we have, right? And that every additional bias you get drives longer time to get things done and planned for. And the other thing, Steve, you mentioned, the commissions wanting to get more involved. In some of our states, like Illinois, it's also the stakeholders, right? Oh, yeah. And so now it's not just the commission and the commission staff understanding it. It's all of these different stakeholder groups understanding why are you doing that. And I think it does take a little different approach than what we historically, because we used to just do all of our planning, say, here's what we're going to do. Well, now we have to go out and say, here's what we think you all want us to be doing. Let's get some alignment around that. And then once we understand what the different constituencies want, then we have to go in and say, okay, now let's do the planning. And then we'll take it back out and they'll say, okay, that's not really what we want. And it takes longer, and it makes it much more difficult to be able, given the time frame that we have to add these new loads on and the new generation. That's, you were asking about what's one of the frictions. That's one of the biggest frictions, is this timing of being able to plan the system to optimize that system in a way that you satisfy all of these different constituencies.
Go ahead.
I want to redo actually on my answer.
You wanna
I
redo?
evolved
Okay.
my thinking as Shawn was talking, which is good. That's why we're here, right? We challenge each other. I'll actually kind of advance my point though. Like, I actually think it's critically important that the commissions and stakeholders, I think you're spot on with that. I failed to mention them, gain that expertise, because again, I feel like a lot of like the gamesmanship here is like, hey, hand over your models. We want to goal seek that to drive a policy outcome. It's like, we got to move past that. And we were talking about this at the break. Like, I think the reason it's critically important because we have to move past the fun and easy parts of resource planning, which is frankly what a lot of the industry revolves around. Like, that's the fun, easy stuff. That's the Star Wars, the Jedi versus like the Sith, right? $20 win versus the $30 nuke plan. It's like, that's easy. That's kind of fun. And my kind of hot take on where industry needs to go in the next 10 years is that resource plans will have to become integrated transmission plans. The grid's becoming precarious, and the easy part of the energy transition is already happening, right? Retiring coal when you have a huge excess of coal is easy, right? So the way I put it is 500 megawatts of retirement now of thermal spinning mass is way easier than it's going to be in 2032, just because of that kind of compounding effect. And so, I'll boldly admit I'm not in EE. I've had to become one really quickly, and I've learned really quickly how precarious this situation is. And so I would welcome a regulator that like really understood the tenets of power quality, inertial floor studies, angular stability, volt var control. All these things need to come into this process. And unfortunately, it's extraordinarily esoteric. It's really, really, really hard, but that's where we got to go.
Well, and importantly, we have stakeholders who are advocating for positions with no understanding of those topics. And I'll throw out an example that I've seen recently. So on the one hand, use hosting capacity at the distribution system level as a driver for investment because we want to enable additional DERs. Okay, that flies directly in the face of the affordability conversation when you're talking about energy burden on low-income communities. How do you start to create a construct that enables that set of trade-offs to become visible? Because right now they're not visible and apparent to the broader conversation. And I think commissions are struggling with how to balance those objectives. Before I go back to my...
Can I just
Oh,
add to
please.
what Steve said? You said integrated transmission plan. I think, at least for us, we have to think maybe a little broader, because if I look at Illinois today and what's in the generation queue, potentially half of our generation would be on the distribution system.
I know.
So then it becomes not just the transmission, but the distribution, just transmission and generation integrated plan that has to go forward.
No question. So before I continue quizzing our panelists here, any questions or comments from the group? Yes, please. Did everyone hear the question? So the question was about, we've got data centers that are coming in and making behind the meter deals with large, in this case, nuclear. That's actually a real thing right now. Pulling potentially 1,000 megawatts out of the market. How do we start to handle those?
Well, I think from our perspective, if they're coming in and doing a deal with a nuclear, or they're trying to do some renewables around that, we still have to understand, as I started earlier, understand the load that's coming on, understand the generation that's behind it, whether it's behind the meter or in front of the meter, because that's going to impact the system. And then we have to integrate that into our planning. And so when you call a black swan event, I tend to think about a couple of different things. One is things like large loads. We can't test every place on the system where a large load comes on, but we do have to think about what happens if we start seeing loads in certain areas that could make sense economically. But I think I also have to worry about what happens if storms are greater in the future, and large things like that, or some of the other black swans that could occur. And it was to the one point I made earlier about, it's not just what's happening on my system, it's what's happening on the next system over, or the co-op that's to the south of us, and what could happen there that could impact our system in a way that could be really significant.
And I think your states are also going to weigh in on questions like the behind the meter data center. I believe Connecticut just put something forward to ask the New England ISO to assess resource adequacy in a case just like that. So again, but I do think we started hearing about large loads at scale, I would say, in the last year. The Grid Strategies report came out in Q4 last year. It wouldn't surprise me if there were other things that are lurking out there along those lines that we just can't see yet. Other questions? Stu? Stu often asks really hard questions, just saying.
So as I listen to the discussion, and I think about, my state, but other states in the Northeast where we divested generation, we relied on markets, right? Maybe Illinois also. We have interconnection queues. We don't have generation planners. I hear a lot about generation planners. I don't know who those people would be. But I'm thinking there's data, right? So we have interconnection queues and data. How do we move forward in a way, right? We don't do IRP, but who should be looking? How do we put together the information that's available in the generation queue and plan transmission and distribution? Is there, and I just keep thinking that there's a ton of data, but how do we pull this all together to have a logical plan that maybe isn't quite an IRP coming out of putting generation planners together with transmission planners?
I have one thought, but I'm going to turn it over to my colleagues here. So again, hard question.
Yeah.
I think one of the things that we talked about as part of the ANOPR that came out a couple of years ago, as far as the capacity planning is often completely separate from interconnection planning. And I think there's a huge opportunity for the industry on that topic to start to pull those two together. I think regions have done it differently. I'm hoping that something comes out of the upcoming order on that. So there's one view. But I also think, and I'll pick on you specifically, right back at you, is that we have additional opportunities as we think about how our transmission and distribution plan together for best reliable and best customer outcome. And I think that there's a lot of low-hanging fruit in planning those systems more effectively together. And some companies, particularly vertically integrated, have been better at that than others. Where there's no disincentive when it comes to the regulatory construct, I believe there's an opportunity there that we haven't leveraged.
Yeah, and I think we're doing more and more of that, which is great. But I think we made just assumptions that the supply is going to be there, right?
Particularly in market regions. Yeah, absolutely.
So, we've assessed that. I think it's, and what I've learned in my time with having integrated system planning is, just despite the extraordinary appeal, and at the end of the day, you're going to find that you're going to have some seam in your process, and the trick is finding what's the optimal seam, and the seam's either going to be G&T or T&D. In terms of those types of markets that you described, what we're doing, we've launched this project Q1 of this year. We're about a third of the way through. Call it Go to the Future project. And what we're actually letting happen, or what we're trying to do, is we're letting kind of cross-economy pathways analysis really drive the stakes in the sand that we need to drive to kind of take a stance on what's going to be the liquidity in the market, and then do you let both power supply liquidity drive into the distribution system, or do you do it more like in a bottoms-up fashion? So we're kind of doing both and trying to synthesize it again around this premise of we think that the right seam is G&T. So that's kind of our approach on your question. I don't have results to conclude for you or claim any sort of victory here, but that's a process we're using right now.
I will answer that. The way I will do it is scenario-based integrated planning.
That's what I mean by pathways.
Yeah, because you can't forecast the future. You don't know what's going to end up being built from that interconnection queue. But if you do proper scenario-based integrated planning, where you may only consider transmission or distribution if half of your queue is in the distribution, then you absolutely want to consider the distribution and the interactions between sub-transmission and distribution. And that will allow you to, one, evaluate the uncertainty ahead of us, but also quantify the risk associated with any investment decision that you may take.
Yeah, so Stu, just to respond, I don't know who should do the IRP in our deregulated states, which is, I think, where your question was. But, what we have to think about is exactly what Carlos was talking about. What are those scenarios out there? And it's kind of interesting, you traditionally think about where's the generation at in our states when we did the traditional IRP. Well, now I have to think about where's it at across the footprint and how can it get into our state. And we're a state that's shutting it down faster than we're building it. And so at some point you have to then say, how do you maintain the reliability given all of the different dynamics going on around us? And is there enough to what you're going to do there? And I really don't have an answer to it. And I appreciate the hard question. I do think it is something that we as a state need to think about, though, because as the reserves in the RTOs are getting slimmer and slimmer, we had, 25, 30% reserves for quite some time. That's going away. And now we're living in a world that's very different, especially as we bring these loads on. And that's going to take a much higher level of integration and coordination.
I don't know that. Larry, do you have views on that?
No, but I'm very slowly making my way over to Brian for his question. But in the meantime, my question is, if you make the move towards more of a reintegrated planning process, is there any friction between existing FERC rules around local and regional planning requirements? Or not, maybe.
Well, when you say is there any friction, I think there's friction between what local or regional requirements may be, state level policies, and then what you're trying to do at the federal level. And so I do, as I mentioned earlier, there is friction between those. If it's between, I don't know if your point was around that or if it was around, who can plan what and the kind of the walls that you have to put in place. And so there, I think, it's who's doing the planning and what information is available that really matters when you go through that.
So I appreciate the panel. I thought it was a really great discussion. I was disappointed, though, because we had G, T, and D, but there's another G at play on the gas. As we think of this fair, it's a leading question for one of the panelists. In the whole sense of fair and affordable, as we think of transition in this electrification world to heat pumps and the affordability for the homeowner, the commercial commercial customers, as well as then the cost of upgrades on gas versus electric pipes or wires solutions. So I just wanted to think of why was there not more discussion on that second G in the totally integrated planning paradigm?
So I can answer that. First of all, we designed the panel around electric because this is wires. Having said that, two of you have a lot of experience in this, and I'll turn it over to you. Carlo?
Yeah, thank you, Cristin. Actually, I may describe some of the work we're actually doing with Brian and his team at National Grid in New York. I start by an anecdote. The first time I traveled to Albany to train National Grid's New York team in our integrated planning solution. For the first time, I was in a room with the gas planning team, the electric distribution planning team, and the electric transmission planning team. And it's been one of the most valuable experiences of mine professionally, not just how much I learned from all of them, but how much I saw them learning from each other and really starting to really understand how they think differently and how they can cooperate. Their goal is to understand what is the impact and value of electrifying gas customers, both from an avoided reinforcement cost on the gas infrastructure, but then the resulting increase in infrastructure needs and costs on the electric side, not just at the electric distribution side, but also the upstream sub-transmission and ultimately in generation. And with National Grid, we've proven a very detailed workflow where the gas planning team, the electric distribution team, and the transmission planning team can not just model their traditionally siloed planned systems together. They can visualize them together, but now they can start doing scenario analysis. What happens if I electrify the gas customers in this territory, in this community, in this neighborhood? What is the impact? How much do I save, or how much reinforcement on the gas do I avoid? But then what is the resulting impact on my electric distribution and transmission? How many service transformers, wires, voltage regulation devices, substation transformers do I need to upgrade to meet this additional demand? And then what is the resulting impact also on the sub-transmission? And this could be taken further to say, well, what is the impact if now I not only consider electrification from gas, but electrification from transportation, electrification from data centers, and so on. And it's sort of a shout out to National Grid for really leading the way in integrating these three planning processes in a very engineer-driven way and in a very focused way. And now this workflow they're going to be able to apply across their entire territory. So starting from a very specific use case, what is the impact of electrifying 400 customers in this community, looking at all the detailed impact, build the workflow, and now they can apply it across their entire territory. And now they can go to the regulator and say, well, we want us to reduce gas emissions from our gas business by X%. I need to electrify this many gas customers in parallel to maybe other non-pipeline alternatives, but I believe electrification is the most realistic one. What is the cost on my electric system? What do I need to do on my electric system to meet that? Now they can truly quantify that in a very detailed manner.
So just to respond, trying to keep it simple. We could talk forever about those interactions with gas and electric and even communications. I mentioned that earlier, that we can't really ignore. And to what Carlos talked about, looking at what happens if, as in the state of Illinois, they would like us to get off of gas, right? What does that mean? Not only from the distribution, transmission upgrades that you have to put in place, how quickly can you do that? But what are the other impacts to other parts of the industry that could impact economic development in your state and areas like that? And so all those things tie together, but it becomes, just looking at generation and transmission distributions, hard enough. Then when you build that in, it becomes even, multiples of that. So trying to keep it somewhat simple.
The other end of the spectrum, less simple. I think Colorado is a good example of where you're having to look at this.
Yeah. You're right, Cristin. Cristin sent out a script, which I took as my note to stay on track here. You're a man after my own heart. I could talk for hours about this. I used to run our natural gas business and our fossil business at Xcel. I have a little bit different view. I'm not personally convinced yet that you can electrify as fast as you think you can on the electric side. I think it's way harder than this industry is giving it credit for. And I just look at the simple numbers of what our two businesses do. And good example, Colorado, 1.4 million customers, peak send out of just less than 3 billion cubic feet of natural gas. That same system on the electric side is 2.1 million electric meters and a peak send out of about 8,500 megawatts. If you were to electrify our existing gas load, we'd have to basically 5 to 6x the size of that Colorado system just to serve that heat pump, air source heat pump load. Not strip heat, not other things, just air source heat pump, which is probably one of the most efficient electrification technologies. So I am just really bearish at this moment still that you're going to convince that many customers to do so. And you're going to do it well, and you're going to do it with high capital efficiency. I think there's some other existential questions embedded into this that you'd have to unpack. In cold climates, the performance is still a little bit of a question. We've gotten some really killer AMI data back on heat performance, and it's intermittent. Actually, it's not consistent, and I think that's been the most surprising result for me. We've seen some really, really high performing heat pumps do really well in some very serious storms that we've had, polar vortex type events, where we've gotten into Denver. We got down to like -23 this last winter for several days. We had heat pumps that worked beautifully and others that failed extraordinarily. And I'm convinced that no matter what you do from a utility perspective, you own that relationship with the customer. No matter what you do, you own two things with the customer, which is affordability and reliability. And it doesn't matter what the technology is if the heat's out, and I think people are a lot more sensitive to heat than they are cooling, you're gonna get a phone call. So, don't take that as I think there's a huge bet to make on hydrogen here. I'm also as pessimistic about that. So I just have like a lot of uncertainty in this space. We have deployed a lot of technology solutions like you've talked about, Carlo, where we're really integrating between the two. And so we're using modeling tools to kind of, show like, gas system, capacity constraints versus electric system, and then trying to come up with like the marginal cost of service solution to really electrify those in a capital efficient way. So we are doing that. I think the results are kind of, indeterminate for now. I have a hard time thinking about how this works at, 10 million customer scale. The last thing I'd say though, just kind of more philosophical, is just, I think it'd be a failure though of our society if we just turn a blind eye to that asset. I think it's a tremendous asset that we've invested in. It's a massive system, the pipeline grid across the United States. I've had my team do this calculation for me. It is the world's biggest battery. So you could take just our Fiesco system, which has about 2.8 billion cubic feet send out. If you just convert that on an energy basis, it's about 10 times larger than all the other utility scale battery installations put together. Now, I'm not saying that's like, a nail in the coffin of batteries per se. I just think to me, it really speaks to the energy efficiency, energy interchange, which is 3,400 to 1. That's the conversion factor. I think we'd be remiss as a society if we just turned a blind eye to that. And the other thing that concerns me too is that I think this is not a light switch, no pun intended, that you'll flip off. There is at least 4 to 5 decades of natural gas operations that we need to endure here as a country. And I do think safety is an imperative. I am concerned that regulators are thinking about this like an emissions academic construct. And I think there's a really strong imperative to continue to invest in safety for those assets. So TBD.
I would maybe want to add that
Yep.
the need to coordinate planning across electricity and gas is not just at the customer level, is also at the bulk system level. There is more than 1,500 gas-fired power plants in the continental United States. I'm not aware of a single one that stores gas. Their ability to generate electricity, their ability to respond to the flexibility needs of the system depends on the ability of the pipelines to deliver gas at a minimum pressure when the power plant requires it. The power system in the United States has never been so dependent on the gas pipeline network than it has today. Electric generation by gas is the highest it's ever been, around 40%, which means in many times of the year and in many regions of the country is much higher than that. It can be 80%, 90%. And now you have extreme weather events like it happened in many occasions or in several occasions, like in Texas 3 years now, where that gas is required to meet heating needs, and at the same time it's required to power generators. And you may end up in a situation where the gas infrastructure isn't built to meet both needs at the same time. And then the question is, how do you solve that? Well, you can invest in pipelines, you can invest in underground gas storage near gas-fired power plants, or you can invest in transmission, as an example, or batteries, or whatever. And only a coordinated planning process will be able to quantify the trade-off between these different investment decisions.
One other quick point. It's a great point, Carlo. You got me thinking. Man, the other thing that we've learned too, as we've investigated this, is gas versus electric system is designed to different technical standards. So, I mean, the gas system historically is a lot more conservative. It's built to somewhere between like a 1 in 30 to 1 in 50 year design basis. Electric's 1 in 10. And you might have some N-1 contingency planning in there, but that's like an outstanding question we have is, will customers tolerate that difference in probabilistic risk assessment? Because they're different technical codes that you're designing to.
Well, I always have to play the bad guy and call these things off at a certain point, because this could go on for quite a while. But join me in expressing our appreciation to Cristin and the rest of the panel for a really interesting discussion.